students, welcome back to the another session of our artificial intelligence. Right now, we are covering the different strategy of the artificial intelligence. So, in this video, we are going to learn uniform cost search algorithm, where the graph or tree is associated with the some cost. That's why we have to think about how to traverse to reach the goal with the least cost. Let's start. So this is a uninformed or blind search which have only information regarding how to traverse. There is no prior information regarding the route details, all the information. Only it has the information how to traverse. It is basically used for the weighted graph or T where the various cost is associated with each edges. So here what happened? When we got a weighted edge or graph, then we have to go for the uninformed search algorithm where the cost means the cost, or we can say it is a weight associated with the each edges or links is called as the weighted graph or weighted tree. And this type of problem, this type of parse searching is from one node to another node, or so to get a goal node, we are using the uninformed cost search algorithm. It can be treated as a variant of a Disaster algorithm used by the graph theory, and it is very useful when the graph have different weight edges. So whenever different, as we are already know, this is only associated with the tree or graph if the weight or cost is associated. The main objective of this searching algorithm is to find minimum cost from start node to the goal node. This is the main objective of this searching algorithm. The main goal of this searching is to find lowest cumulative cost to the goal node. So here we are main objective to find out cumulative cost, not the individual cost. Cumulative cost means the cost from the root node to that goal node. It can be treated as a breadth first search algorithm if the cost of edges are same. Generally, what happens whenever you go for weighted graph or weighted tree, at that time each and every edges has the different cost or weight. But if the each and every edges has the same cost, then this algorithm is same as the breadth first search algorithm. So for implementation, it uses the priority queue. Priority is given to the lowest cost here. So now we have to understand what are the basic terminologies used in the uninformed cost search algorithm. So this is, for example, tree is given. Here the tree is given and it is associated with the various cost, or we can say it is weight from A to B. If we traverse from A to B, cost is 1. A to C, cost is 9. If we traverse C to G, cost is 8. B to D, cost is 3. So each and every edge is associated with the cost, means from traversing from one node to the another node, this much cost is required. So this is our level 0, this is level 1, level 2, level 3, level 4. So all the level is given. This is a tree structure, that is the weighted tree. So first terminology it is used, that is the called as the priority queue. So here priority key is used for to store the node information. The node with the least cumulative cost is expanded fast, which guarantee that the search always explore the next promising path fast. So this is the need of the priority queue. Second one is the past cost. So what is a past cost? The cost associated with reaching a particular node from the start node, and it calculates the cumulative cost from the start node to a graph node or root node to the tree. For example, I want to calculate the path cost of a G. So what is the path cost? It is total cost or cumulative cost from the root node. What is the root node? A. So if I have to traverse this way, so the path cost for the 8G is 9 plus 8. If I have to calculate this node G path cost, so cumulative means how to reach this G node. First, I have to traverse A to B, B to E, E to G. So 1 plus 2 is 3, 3 plus 5, that's the 5. So path cost for the G is 5. So here what happened? Path cost means cumulative cost from the root node to that specific node. Next terminology we require exploration. So here what happened? It explored the node by expanding least cost node first. What it means that, for example, I have to explore from A to next node. So here what happened? There are two nodes is present, B and C. Now cost is here 1 and here is the 2. So now A explore to which node? It will go to the lowest or least. Which one is the least? A is the least because from between A and 9, which one is the lowest cost? Lowest cost is A, 1. So it will go to this node. After that, next question, B has to go to the D or E. If it has to go to D means cumulative cost, that is 1 plus 3, that is 4. If it has to traverse E, then 1 plus 2, that is the 3. Here 3 plus 1, 4, here 3. So if it traverse this way, then it is 4. If it is traverse this way, it is 3. So in this case, it will traverse to the E. So A to B, B to E. So, and it continue the process until goal node is. So here we, for example, goal node is given. So according to that, it will traverse to until it will not reach the goal node. The path to the goal node is guaranteed to be the least cost one. So here it is guaranteed that whatever path is selected by this searching algorithm, it is the lowest cost. Next one is the terminology we have to use, that is the termination. What is the termination? The searching process continue or continue until we are not reach the goal node. Once we reach the goal node, it will process will stop. And so for example, my goal node is the E. So once I reach the goal node E, then immediately we have stop of there is no chances. For example, my searching is the P. Here the P is not present. So whenever we traverse the least cost and we reach end and there is no goal node is present, at that time also we have to terminate. So this is the basic terminology we have to use in a uninformed cost search algorithm. Now let us understand how the searching algorithm is perform its operation in case of uniform cost search. So as we are already know, this is our start node, that is the A is the root node or start node. Next one is the which one is the goal. Here what happened? G node is represent the goal node. So goal node is G. Now in this tree, there are three goal node is present. 1, 2, 3. Now anyhow, in this algorithm, whenever we reach the first goal node, we have to stop here. So now from A to what are the possible path? B and C is present, B and C is present. So A to B cost is 1. This cost is 9. As it is a uniform cost, which one it will select? As we are know, we select the lowest cost. Lowest cost means this is the one. So now retraverse to this one. Now from B to what are the possible path? D is present and E is present. Here what happened? We have to calculate the cumulative path. So B to D cumulative is 1 plus 3, that is 4. Here 1 plus 2, 3. So now which one it will select? It will select the least cost. So now retraverse from this node to this node. Now here only one path is present, so it will definitely go to this path. And what is the cumulative cost? This is 5. So 1 plus 2 plus 8, that's the 5. So anyhow, it will traverse to this one, and after traversing, it will find that it is a goal node. So what is the path cost? Path cost is 1 plus 2 plus 5, that is 8. Path is A to B, B to E, E to G. And how the uniform cost search algorithm use the priority queue for its implementation. So this is our queue is represent. We know. So insertion is done from one end and deletion is done from another end. So insertion we call as the NQ, deletion we call as the DQ. So here the searching start from the root node. So first we have to insert the root node, that is A. We insert the A. After that, what happened? Whenever we have to go for the deletion or DQ, at that time, what happened? We have to make this node is the visited node, and all the children is going to be inserted into the queue. So now here what happened? If we make the deletion, then what happened? We have to make the visited node equal to A. Now we have to remove the A and we have to insert which value? We have to insert the children. Children is in B and C. Whenever we are inserting here, what happened? Insertion done on the priority basis. So A and Q, A, B and C, 1 and 9. In between, which was the lowest? So B. So B is going to be insert first, then C is going to be insert. The insertion also done on the basis of the priority value. Now next, which one is going to be delete? B is going to be delete, and B is we make as a visited node. So now we make the B as a visited. After B, what happened? Remaining the children. Remaining children means B has two children, that is the D and E. Now what happened? D is present, E is present, and already inside the queue, C is present. Now we have to calculate the cumulative path 1 plus 3. That is, D has the 4, E has the 3, C has 9. Here what happened? Whenever we go for the insertion, at that time priority queue insert the element according to the priority basis. So which one has the priority more? 3. So it will insert the 3, then D, then sorry, 3 means it is not 3, it is E, then D, then C. So whenever it inserts dot, it done on according to the basis of the priority value. So next one is the deletion, means E is going to be DQ and it make as a visited. So E is the visited node. Then after E, there is only one node, that is G is present. So G means, and G is the goal node. So here what happened? We have to stop because we are already got the goal node. We are already got the goal node. So next we have to make that the we are already reached the goal, and we have to make the it is visited node, because G means what happened? 1 plus 3 plus 5, that is 8. So for G it is 8. So total path cost. So now what is the path? Path is A to B, B to E, E to G. And path cost is 1 plus 2 plus 5, that is 8. For example, our start node is the A and goal node, for example D. For example D. Now here from A there are three ways it can traverse, that is the F, G and B. So which one is the lowest? Lowest is the 2 path cost, so it will traverse A to B. Now from B to what are the possible? That is G is possible and C is possible. So cumulative we have to calculate. So here from B to G, if I go from B to G, then what happened? 2 plus 6, that is 8. Here 2 plus 4, that is 6. So which one we have to select? We have to select this one. Now from C, C to H is present, C to D is present. If we traverse D, we will get the goal node immediately. So anyhow we have to traverse to the, anyhow it is the least cost, so anyhow it will be select list. But here what happened? 2 plus 4 plus 2, 6, sorry 8. Here also 8, but anyhow here it will get the goal node. So anyhow it will traverse. So here the path is A to B, B to C, C to D. Path cost is 2 plus 4 plus 2, that is 8. Next, the time complexity. So the worst case complexity of the uninformed cost search algorithm is order of b to the power d, where the b is the branching factor of the search tree, d is the depth of the goal node. Then space complexity. The space complexity of this algorithm is also b to the order of b into d, but it can be further, it can be reduced to the b to the power d. But if we have the binary heap for the priority queue, where it is the b is the branching factor of the search tree as well as the d is the goal of the depth of the goal node. So whatever goal node, according to that, the depth is calculated. Then we have to check whether it is optimal or not. It is always optimal, as it not only, it is because it only selects a path with the low cost always. So it is optimal. Next one is the completeness. It is complete if, means that if there is a solution, then this search strategy definitely will find out the solution. Next, we have to know what are the advantage of the searching algorithm. It considered to be optimal solution since at each state the least path cost is considered. So anyhow, we are getting the solution with the lowest cost. It helps to find the path with lowest cost, that is cumulative cost, inside a weighted graph having various costs associated with the edges or links from the root node to the destination node in case of the tree, or it can be a start node to the goal node in case of a graph. So let us understand what are the different disadvantage of the algorithm. So first one is when we are inserting the data into priority, it's required to be sorted. As we are already covered, whenever each and every time we are inserted in data, means whenever we perform deletion or DQ and make the node as a visited, and after that we are inserting the all the children. At that time, what happened? We have to sorted the queue each and every time whenever we go for the insertion. That's why it is computationally very complex, because for each and every insertion we require the sorting the data. Storage requirement is exponentially large because each and every time we have to do so storage requirements is more. There is a chances of infinity loop since it takes every path going from the source to destination, because each and every time whenever it travels to the next node, it has to calculate all the cumulative path. That's why there is a chances of infinity loop. So this is all about the uninformed cost search algorithm. Hope you are able to understand the concept. If you have any doubts, you can ask me in your comment section. I will definitely try to help it out. Thanks for watching the video. Please subscribe the channel, like the channel, share the channel. Thank you so much.